Okay, so welcome back, Math 3. I know it's been a while since you guys probably picked up a pencil and did some math, and so I'm going to just finish up section 8.6, and yeah, we'll conclude chapter 8. All right, so if you can recall all these terms over here, frequency is actually going to be a new term, period, amplitude, vertical shift, and there's a phase shift. And you can have that for a sine graph or a cosine graph. So let me just define all these terms with you in the context of a graph. So let me sketch out my graph over here. And so here's my sine graph. And let's start with the amplitude. So if you recall, so this is my sine x graph. If you recall, the amplitude is given by this formula. It's 1/2 max minus min. And you can think of it also as the distance between the midline, right? The midline for my sine graph is just y is equal to 0. You can also think of it as the distance between the midline and the max, or the distance between the midline and the min. Okay, so remember, this is a maximum coordinate. Pi over 2 comma 1, that's a max, and typically the max is the y value, and over here is a minimum, and the y value is the minimum. Okay, all right, so the amplitude, if you remember, is 1/2 max minus min, or you can calculate it from the graph by just saying, hey, the distance from here to here, it's a vertical distance, it's just 1 unit, right? And of course, you don't have to calculate it, but you can. It's 1/2 1 minus -1, just using the formula. In this case, you're just going to get 1. Okay, and the amplitude is always positive. You know, I had some math analysis students give me a negative amplitude on their most recent test, in which case I marked them wrong, because the amplitude is always referring to the vertical distance between the midline and the max, or the midline and the min, or you could use this formula 1/2 max minus min, which should always give you a positive number. Okay, so that's the amplitude. The period, you guys also know what that is, right? On this graph right here, the period is basically the horizontal distance of one cycle. So over here for my sine graph, remember this is my f of x is equal to sine x, in case that was not stated explicitly. Before it starts repeating again, right, it's going to go up, it's going to go down, then it's going to go all the way down to the max, and then back to the midline. The distance from here to here is just going to be one cycle, or sorry, is one period. One period is defined as the horizontal distance of one cycle, and that's just 2 pi minus 0, in which case just 2 pi, right? And so the period, let me write this down again, is the horizontal length of one cycle. And if you remember, right, the period also has a formula. It's given by 2 pi over b. The period is 2 pi over b, absolute value. Remember, the period is also going to be a positive number because it's a distance, right? Horizontal length, horizontal distance, distance is always going to be positive. Okay, so that's just a quick review of a period, amplitude, phase shift. I'm just going to kind of work backwards here. Phase shift is how much you shift it horizontally, right? It's basically your h value. There's really no formula for that. And I mentioned a vertical shift basically is your k, but you might want to insert this, right? The midline basically is your k value. Y is equal to k, right? If I go back to my sine function, the midline in this case is just y is equal to 0. Okay, so the new term that we're going to cover today is called a frequency, and the frequency kind of means what it sounds like. It basically relates the number of cycles, and it relates it to time. And so let me just define it here for you. The frequency is the number of cycles per unit of time. And it also has a formula. It's basically the reciprocal of your period. So your frequency is 1 over your period. And we'll talk about that in the context of example number 1. Okay, so we're going to move on to the first problem on your notes here. It says an audio meter produces a pure tone with a frequency of 1000 hertz cycles per second. The maximum pressure P produced from pure tone in from the pure tone is 20 millipascals. Write and graph a sine model that gives the pressure P as a function of time, where T is in seconds. Okay, so the way I would start this problem right here, it says write and graph a sine model. And if it's a sine model, let's write down the model here, right? It says write and graph a sine model that gives the pressure as a function of time. So my function right here is going to be P of T is going to be equal to A sine of dt. Now notice I did not include a phase shift over here or a midline. And the reason why is that they only give you limited information on this problem. So we can only determine the amplitude and the horizontal horizontal stretch or shrink factor. Okay. All right, so we now know it's a sine function, and we need to calculate basically what our amplitude is and what our horizontal shrink or stretch factor is. And so let's start with this piece of information, right? They tell you that the frequency is 1000 hertz. And we're given up here that frequency is 1 over the period. So we can calculate what the B is, right? Because frequency is given by 1 over P. And the period, right, if you remember, is 2 pi over B. So I'm going to substitute that in here. And, you know, this looks kind of complicated, right? But you can kind of flip this, right? Frequency is B over 2 pi. And now, if you cross multiply, your B is F times 2 pi. And what was our F? Our F was 1000 hertz. So we're just going to multiply over here. Your B is 2000 pi. Okay, so that's what we're going to insert into this number right here, or this letter, I should say. And the very last thing we're going to need is the amplitude. Now notice it says here the maximum pressure produced from the pure tone is 20 millipascals. Keyword right here is maximum. And maximum, remember, just refers to the Y value of your max, the location of your max, right? If I say, hey, where is the max? You would say pi over 2. If I say, what is the max? It's just going to be 1. So likewise, if they tell you that the maximum pressure produced is 20 millipascals, the amplitude in this case is just 20. And so I have my final answer of 20 sine 2000 pi T.